Okay, in this notebook, we're going to go over dictionaries, which are an extremely powerful and flexible uh, data structure collection in Python. And as a little philosophical question, did the first dictionary contain the word dictionary? At least in English, it did not. So dictionaries are mutable, non-sequential collections of key value pairs. Okay, so they're mutable like lists. They are non-sequential, which is different from either of the previous three that we've looked at. Um, and then they consist of key value pairs. You can think of it as the word and the definition. Excuse me. So we create dictionaries with a curly bracket, including a sequence of key separated colon value pairs separated by commas. Now, dictionaries cannot be sliced, and that's because they're non-sequential. So there's not any ordering from 0 to 10, say, like we had with the lists and strings and tuples. Now, the value in a dictionary can be anything like a list. The list, you can have functions, lists, dictionaries, integers, etc. And the same thing here with dictionaries. But the key must be an immutable object, so the key must be some element that can't change. So, first question here, can a dictionary contain a dictionary? Yes, because the value can be any Python type. So here, I ask, is this a valid Python dictionary where I have as a key a tuple 1, 2, 3, and a value is a tuple with the characters A, B, and C. Well, this is a perfectly valid Python dictionary. So is this a valid Python dictionary where I have as a key a list 1, 2, 3 and a value the tuple ABC? So in this case, I get an error, unhashable type list. And that's essentially saying a list can be modified, it can be changed. And so it cannot be used as a key for the dictionary. So we can think of the key as a generalized index, whereas in a list, the index is always the sequential numbers 0, 1, 2, 3, etc. In a dictionary, that index can be any of these immutable Python objects. We access the value in a dictionary the same way we do with lists and tuples and strings with the square bracket notation, where instead of the numeric index location, we provide a key value. So dictionaries are very powerful, as I said, and versatile data structures. They're actually what Python uses to index their classes when we talk about object-oriented programming. So here I have an example dictionary, which I've assigned to a variable CBC for a complete blood count. And here I'm using I have a key WBC, which is a string, which white blood count, and the value that's matched up with it with a colon is 5.9. Then I have a red blood count with the value 5.23, hemoglobin with a value 15.9, hematocrit with a value 45.5, etc. So I can access the individual elements by providing the key inside the square bracket indexing. So if I want to get the white blood count, hematocrit, or I don't know what I mean by MCV, but you'll see that when I do the white blood count, I get 5.9. When I do the hematocrit, I get 45.5. But when I try to access MCV, I get a key error. The dictionary has no key MCV, so there's no value to return from that key. So a safer way I can do that, instead of trying to access a dictionary and finding that I don't have that key and throwing this exception that may halt my program, is dictionaries have a method named get. And get allows us to safely return a value from the dictionary. So if the dictionary does not contain the key that I provide, get will instead return a specified default value, which by default is none. So here, I'm again going to access my CBC and ask it to return to me the value associated with the key MCH. In the first case, it just returns none, which is the default to say there was nothing there. In the second case, I'm telling it if the key MCH is not in the dictionary CBC, return the value -1. Okay, we can return the keys and values of the dictionaries with the keys method and the values method. We can return the tuples of the key value pairs with the items method. And then that allows us to various things we can do with asking questions about the keys, or we could sort the keys and then iterate through the list in an ordered manner. Because Python dictionaries are non-sequential, we can't guarantee what order the key value pairs would be printed out if we were to print out the dictionary. So that's just a potential gotcha if you're not aware of. There are two extensions of dictionaries that are defined in the collections module. The first is a default dictionary, and we'll use this quite a bit once we get into ifs and for loops, which we'll talk about next week. But in the default dictionary, whereas before, if I used, if I tried to access a dictionary element that didn't exist, I would get an error. Or I could use get to return a default value associated with that value, that key if it didn't exist. The default dictionary allows us to specify what, if there's not a key value, if that key doesn't exist in the dictionary yet, we can automatically assign a value to be associated with that key. And so in this case, I'm creating a default dictionary, which I call DD1. And I'm going to tell it, this is going to be an integer default dictionary. And the way this will work is if I try to access the value associated with a key that doesn't exist, Python will assign a 0 as a value to go with that dictionary. So here we have an empty default dictionary. Let me just print that out so you agree that it's empty. See, we got this bracket with nothing there. And now what I'm going to do is I'm going to access the value that's associated with the key capital A, and I'm going to add 1 to it. But we don't have a key of capital A. And so what Python will do is say, okay, this key of A has a value 0, and then Python will allow me to add 1 to it. And so now we have the dictionary contains a key value A and a value of 1. I can also define a default dictionary that is a list. And so now, if I access a key that doesn't exist, it will create an empty list. And then I can manipulate this. So in this case, I'm going to access a key names, which doesn't yet exist in the dictionary. Python will create an empty list, and then I append Brian to it. Okay, I have a separate notebook on sets, but sets are unique collections of values, and so in this case, I'm creating these red. I have this list S consisting of pairs of tuples, red, 1, blue, 2, etc. And I'm going to create a default dictionary that is a set, and so I can only add unique values to it. I'm iterating over that collection, which we'll talk about later, and so I'm probably kind of jumping the gun a little bit in including this. But what do we see here? So this is using red, blue. The keys have to be unique. And so the keys end up being the colors. And then I'm adding to the set the values that I encounter. So I have a red and a 1, a red and a 3, a red and a 1, but sets are unique, so I can only have 1 1 in the set, so that doesn't change it. And with the blues, you see I have a blue 2, a blue 4, another blue 4, but the sets are unique, so I only have 1 4 in the set. A second modification of the dictionary is an ordered dictionary that preserves the order that things are added to the dictionary. And so you might ask, why not always use ordered dictionaries? So you have this sequential aspect to it. And that is that you degrade performance because you have to now keep track of the order that things were added. So if you don't need to know the order of the dictionary, which is usually the case, it is more efficient to use the regular dictionary rather than an ordered dictionary.